Okay, so last time we set up a problem where we had a girl at an arcade who was choosing between pizza and Metal Slug. And so now we want to solve this using two different methods. And the first method we're going to use is the corner checking method. And this assumes that we've got these constraints here, that she can only use so much time and she can only use so much money. And there's one location where she uses all of both. And we can find that location by setting up the constraints as linear equations. We'll get two linear equations that we'll then solve by doing some substitution. So the first equation is that the total time spent, 1 hour, is equal to 0.25 times pizza plus 0.16666 times Metal Slug. Right, so we use 1/4 of an hour in pizza and 1/6 of an hour in Metal Slug, and that's going to equal an hour if we use all the time. So that's that. And then if we use all the money, we have $8, and we get $4 we spend per pizza slice, and 25 cents per Metal Slug game. Okay. So these are our two constraints. So this is our time constraint and this is our money constraint. So we are going to check whether using all of the time and money is best. It might not be. So it might be the case that just eating pizza is the best thing to do. And if that's true, then we won't use up all the time because we don't have enough money to use all the time. It might be the case that just eating pizza is best. It might be the case that just playing Metal Slug is best, or it's best to mix between the two. Those are the three choices. Because this is a linear program, it will be one of those three things. So to do that, we need to solve this system of equations. So I'm going to multiply that first equation by 16 to get the p's to cancel. So the new equation is 16 equals 16 times 0.25 is 4p plus, and then we need equals 0.16667 times 16, 2.6667 times m. That's our new equation. So do you see this equation and this equation are the same? This one's just scaled up by 16. This is 16 is 16 times bigger than 1. 4 is 16 times bigger than 0.25, and so on. So right here, this one and this one are exactly the same information. But now we've written it in a nice way so that we can subtract this one from this one. So if I do that, 16 minus 8 is 8. 4 minus 4, 4 p's minus 4 p's is 0 p's. So we've gotten the p's to cancel. And then 0.26667 minus 0.25 is 2.41672. m's. Okay, so we see that we've got a new equation that doesn't have any p's in it. We just have 8 equals this other number times m. We can solve now for the m, which is going to be 8 divided by that 2.41672 number. So we play 3.3 games of Metal Slug as a possible solution. That means we can then figure out how much pizza we're getting. So if I take 0.25 times that, that means we're spending that much money on Metal Slug. So this is games. This is dollars on games. So that means if we spend all the money, we've got $8. So I'm going to do 8 minus the money on games. And get that. That's the money on pizza. So money on pizza, which means what's the number of pizza slices? It's going to be $4, or this number of dollars divided by $4 per pizza slice. So now we've got our number of pizza slices and our number of games. Right, so if we do 4 times this plus 0.25 times this, we get $8, so we spend all our money, and 0.25 times pizza plus 0.16666 times games, we use a full hour. Subject to some rounding error, obviously. Notice now we have kind of this weird result where we are eating 1.79 slices of pizza and playing 3.3 games of Metal Slug. If we restrict ourselves to the integers, this becomes a much harder problem. So then you basically have to guess all of the whole number combinations that work in a whole neighborhood around this point. So if we leave it in decimal form, we have a much cleaner location for the optimal choice, even though it doesn't actually make physical sense. So in this case, the fact that we've used decimals matters because we're getting decimal answers, but in many cases you won't. So what remains now is to see whether doing this many of the two things gets me the best outcome or not. So I'm going to take this times 0.5, that's the number of utility points I get for playing games, and this times 2, that gets me my number of points, or utility points, right there. That's our, if we do 1.8 pizza slices and 3.3 games, that's how much we get. So what remains to check is whether the other possible solutions are better. So what if we just eat a full 2 pieces of pizza, right? They're $4 each, we've got $8. Let's just eat 2 pieces of pizza. Or we're going to have 2 pizza times 2 utility points each. That only gets us 4 utility points. So the combination is better than just straight eating pizza. And what about Metal Slug? Well, if we do Metal Slug, we're restricted on time. And so the best we can get in is 6 games of Metal Slug, and they're worth 0.5 each, so you would get 3. So if we play only Metal Slug, we get 3 points. If we eat only pizza, we get 4. If we do a combination of both, we get 5.24. These are the 3 corners of the optimal solution that we need to check to figure out which is best. Sometimes it's the all games solution, sometimes it's the all pizza solution, and sometimes it's the mixture. and it turned out to be the mixture. So our answer would be this number of pizza and this number of games. Okay, so that was using the corner checking method, where we set up the linear constraints and solved for them. So that was important to see what's going on behind the scenes, but the reality is it's much easier to use Solver to guess and check our way into the right answer. So if we have, so here's our, let's see, so our benefit function can be set up down here. Let's copy this, copy. Let's do this again using Solver here. So I have these two, this is my choice value, and that is going to produce the number of, oh, I forgot to copy my labels here. Okay. So this is our choice. This is the benefit. This is the total benefit we get given that choice. So now let's look at how that would look using Solver. So to install Solver, you have to go to Excel, File, Options. Can't quite see this very well, but you get this big dialog box, and you go to Add-ins. And then there's this button down here. It says Go. Click that. And then, see, I have Solver add-in checked. You want to check that and then push OK. I hit cancel because I already have it, but you'd hit OK. And then it shows up in the Data tab. So there's, you can see it says Solver right there. So we're going to solve this using Solver. So we want our benefit. So Solver does a few things. So the objective function is the thing we're trying to maximize or minimize or set to a certain value. We're trying to maximize benefit. So we want to maximize the benefit. Notice I click here, select my cell, go back. So we want D85 to be maximized. By changing now, we want to change. Oh. We want to change our two choice cells here. Right, by changing these two. So the objective cell is the formula for your benefit function, and the changing cells are the inputs where you're just typing numbers. There's no formulas. You can never put a cell that starts with an equal sign in the changing variable cells. Solver will freak out. Okay, now if I don't do anything to this and push solve, what's going to happen is we're going to be eating very quickly infinite pizza and playing infinite games of Metal Slug. That is a maximum of sorts, but it's not a feasible one because we actually are constrained to some degree in our problem. So we need to add this constraints into this problem. So that occurs down here in the subject to the constraints thing. So I'm going to add a constraint. Our constraint, we want the total time to be less than 1. Okay, we need the total time to be less than 1, so I'll add that. And we need the total money to be less than 8. So I could push add if I wanted to add more constraints, but this is the last one I'm adding, so I'm just going to push OK. So now you can see we are forcing this to be less than 1 and this to be less than 8. That's our total time right there and the total money spent there. We're going to maximize those two benefits subject to those two things. Make sure they're not linear, and then push the solve button.